Oh, hey, engineering design kids. It's good to see you. I'm just hanging out in my basement trying to be trendy. Let me know what you think. Hair's grown in, whatever. Good to see you. Hey, hope everyone's doing all right. Let's get this road on the show, shall we? All right, let's do her.
Uh, yeah, relays. This is where we left off before spring break. I hope you've had a great break, but it's now time to pick up where we left off. I'm still kind of brainstorming. Figured I'd put all the time into making that crazy relay. We might as well have you guys do a relay program. But yeah, so I was hoping that you guys could practice with this, but I'd like to recap it first before you try, and that's going to be the plan for week one. When we meet during class time, we're going to talk about a plan for the rest of the quarter and maybe some different options for you. I've got a couple ideas. Anywho, let's go ahead and recap, and can't wait to see you at our meeting on Tuesday. Beautiful. All right, let's do this thing. Where's my ink? Oh, it's not plugged in. Wow, Slagle, God, you had all this time to prepare. Literally 3 weeks to make this lesson. Didn't even have the pad plugged in. We're good now. Let's go ahead and get started. All right, look at that. Beautiful. Lines are drawing. We are in great shape. Let's give this relay a nice toupee. Oh, just excellent. Oh man, look at that. Wonderful relay. Okay, so relay, what is a relay? A relay is a tool that allows us to control a load voltage or a high voltage circuit with a low voltage circuit. That's beautiful because we can keep two circuits separated and control circuits like a thermostat, right? To turn on your boiler in your house, you don't need 120 volt power to send a signal to turn on your boiler, so we use tiny little thermostat wire. Tiny little circuit controls a relay in your boiler to kick on 120 volt power. Sweet. Cool. So this uses 5 volts direct current to turn on up to and including 240 volts alternating current. I don't know if I went over alternating and direct current with you guys, but direct current, one direction, alternating electricity, electrons are going like this, shwit, 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 back and forth. In fact, they're going pretty darn fast. If I haven't taught this already, we're going to get a quick review. If you look up the lights right now, go ahead, take a peek. Don't have the lights on? Turn them on. Better turn them on. The lights are blinking. Our eyes cannot detect that they are blinking, but the lights, the electricity in our house is alternating current. Electrons are moving back and forth. What's moving them back and forth? The power plant, there's a big magnet. Magnet is spinning, pulling the electrons forward. When it comes back this way, it sucks them back and then pushes them forward and then sucks them back, and it's spinning on a big rotating axis. So that's how we create alternating current in our homes. But we can control alternating current with direct current, 5 volts, low voltage, high voltage. That's the point of a relay. Now, I do not, please, guys, please do not try and control high voltage and mess around with high voltage electricity. This is just for learning. It's a learning exercise. We got enough to worry about with the coronavirus out there, okay? So please be careful. Let's go ahead and move along. Okay, yeah, so relay is an inductor. Remember, inductors, they take a while to create a magnetic field. It's got a big coil. So they take a while for this field to kind of charge up, and it takes a while for them to collapse. And that's the reason we have to have a flyback diode, because it is an inductor. So we have the input or the control circuit that comes in through that coil there. That coil charges up, and it's going to suck that lever down. That plunger right here, plunger is going to get sucked down and connect to the other circuit on the other side, the high voltage there. So we have our input, and so it runs through the coil, which creates that magnetic field, which is going to flip this switch. So this is our separated high voltage. High voltage is right here. Beautiful. High voltage there. And this is our control circuit down here, This little circuit is low voltage. Okay, and we create this magnetic field. Bloop. So what we did in class is we were controlling those two lights. And basically what I did is I took the hot wire from the wall and I soldered it onto this common terminal here. And then when we soldered that on, basically I had two possible outlets. The hot from here went to one light, and the hot from here went to another light. So those go off to a light. Bada bing, bada boom. There's the light bulb. This came down. This went off to a light. There's the light bulb. This came down. And then what I did is I took these two wires, joined them back together, and then sent them back to ground. Not connected to here. They went off back to the plug. So like, actually, let me just draw that little plug in. I'm going to take this all the way around. Let's just go all the way back this way. Here's our plug, our wall plug-in. And I had one wire go to here, one wire come in there. So don't try and wire this at home. Boy, that got messy really fast. You guys get what I'm saying. Low voltage circuit controls this little switch. It's just a little switch. That's all it is. Swing. How is it different from a transistor? Answer that. Transistor is low voltage controlling low voltage, right? We can kind of create different voltages with a transistor. With this, they're completely separate. Completely separate. Fantastico. Next slide. I want to talk about your projects. I've not forgotten about your projects. I know you guys have put a lot of work and thought into those projects. And so please come to the meeting on Tuesday so we can talk about those. That would be stupendous. Okay. This is broken down separately. One thing I got to mention, now this is the one from your book, and I will post that little book that's in your Arduino kit on the website. Not all relays look like this. And in fact, the one that's on Tinkercad, which is what we're going to be using because you guys don't have your Arduinos, it doesn't look like this, but that's okay. The same basic idea exists with the relay that you'll see. So we have our, let's see, we have our control circuit right here. Control circuit coming in, and then we have our common terminal. This is where you would hook up something that's really high voltage over here. Even though it says it's just going to an LED, which is just 5 volts, you can do low voltage or you can do high voltage there. Okay? Super. Stellar. That's the wiring diagram for what's in your book. Here's the actual diagram from your book. And I'm going to show you how I altered this. So in my drawing, when we get to Tinkercad, I got rid of these. I did not see them as a necessity. All these two wires do is they bridge the positive terminals over here, which are being charged from your Arduino, right? So this is going to the positive on the, oh, can I fit that to width? Whoa. Okay. That's positive on the Arduino, that's going to negative Arduino. All these, though, is charge these rails over here. So in my diagram, I have this wire arcing all the way back to get to positive on the other side. And I have this wire coming over to negative over here. I may have them flipped because I had to turn this around, but it's the same basic idea. Okay. Sweet. Bingo. So go ahead. You're going to be drawing this in Tinkercad, but I'm also going to show you my drawing in Tinkercad. So if you want to get this to work, that would be the first step before you start the assignment. Yeah, so what's your assignment? Well, we'll get there in just a sec. Apparently there's one more slide. This is what the Tinkercad Relay looks like. Yikes. Okay, so for the Tinkercad Relay, the control circuit is indicated by a coil. Okay, this is a coil, this is our control circuit. So these 2 points being these 2 lines. So this right here is our control circuit. That is how we turn this switch on and off. Now on Tinkercad, you will actually be able to see this line flip flip over. This line is going to tick over, okay? You'll be able to see that flip when this is activated. So you can test and troubleshoot your relays and make sure that it's working when you see that thing flip over. So this is our control circuit. And then I'm going to grab another color here. Red. Yes. Yeah. Here is our high voltage circuit. So this is coming down, and then it beep, jumps over. And that thing is going to switch kind of back and forth between those. So what you want to do when you're using this, you have your control circuit. The control circuit is what is hooked up to our transistor, the one in blue. And basically, so this comes down, comes through here, and then is going to switch between these two leads, okay? And this is just if you want a constant circuit running through. You can hook it up to either one of these points. It could be the one on the left or the one on the right. It doesn't really matter. Awesome. Great. Excellent. Let's see here. Where else are we going? I think we covered it all. Yeah, so these 6 points are analogous to these 6 points on your relay. Your assignment, as promised, was you're going to create a three-way switch controlled with 2 ports on your Arduino. Your circuit should have 2 relays, 2 transistors, 2 flyback diodes, 1 LED, 1 resistor, and that resistor should be connected on the circuit that's connected to your LEDs, which would be the high voltage circuit. The high voltage circuit is going to be the one with the resistor, and I believe that's 330 ohm. There is a very detailed assignment description that you can check out on the website. It has all these details. Yeah, and enough wires to make the circuit look pretty. Try and make it look pretty. Beautiful. Yeah, you guys have got this. Make it look as pretty as possible. And that doesn't just mean brightly colored wires. I mean aesthetically pleasing. Okay, I'm going to move on. Okay, how a three-way switch works is you have the hot terminal coming in, or neutral, or whatever. You have the hot terminal coming in, and then when you flip the switch, so your house, it is required by building code that you have a three-way switch on the stairs for safety, so you don't have to run up the stairs to turn the lights off and then descend the stairs in the dark if you sleep downstairs, or vice versa, right? You don't want to have to go to one side of the stairs and then go across the stairs while it's dark. So it is building code that you have a three-way switch at the top of the stairs and you have a three-way switch at the bottom of the stairs to control the same light. 2 switches controlling 1 light. How does this work? Blah. Okay. Well, you have a switch. Basically, and there's many ways to wire a three-way switch. This is not the only configuration, because you can have the switch you can have the light bulb in between the switches, and it starts to get complicated. But it's all the same basic idea. It won't make much of a difference. Okay, so how it works is, as long as these 2 switches are connected to the same lead, the light bulb will be illuminated, right? So if you're in this configuration, you could turn either this switch up to here to make it connected and the light bulb turn on, or you could turn this switch down to here and it would connect and make the light bulb turn on. Oh, hello, Lewis. Have you come to help me film my video lesson? Fantastico. If you want to turn the light off, it doesn't matter which one you flip. The light is going to go off. Fantastic. Great. Okay. Same thing here. If they're switched, this is currently in the off state. You flip one, it's going to be on. It doesn't matter which one you flip. Okay, if they're both on the same lead, which we can't really see because that's in our walls, that's why you can go up to the top of the stairs and be like, flip, and then come down and then flip, and then go back up and then flip. And then so it's why you can have the light bulb be on with these things in different configurations, which is kind of cool. So like you could have the light bulb be on and this switch is facing up, or you could have the light bulb on and this switch is facing down. It's pretty miraculous. Yeah, so let's go ahead and take a look at Tinkercad. This video is getting long. This was supposed to be like a 6-minute. Sorry, guys. You can expect more of this now. I've been trying to, I've been really using my time wisely and definitely not wasting any bandwidth on anything that wasn't school related. So I can pretty much promise you that. Ignore that for a second. Let's go ahead and get to Tinkercad. Okay, when you get to Tinkercad, you should be able to log in using your Google account from the school. Please use your school district one provided, and also please use your normal username and password that you'd normally use. So when you log in, you can say, would you like to create an account or would you like to log in with Gmail? Well, you should have Gmail signed in on your browser, and you're just going to log in with that Gmail account. When you get there, don't go to 3D Designs. I suppose you could. Let's go to Circuits. When you go to Circuits, you're going to create a new circuit, and we're going to take a look at this bad boy. So this is my adaptation of the circuit from the book, which is linked on the website. I think it is Circuit 13. So I would try getting this assembled first and working first before you, I guess, try and do your challenge. Oh man, I hope I've covered everything. So yeah, let's walk through what's going on here. So we have the ground and 5-volt hooked up to these rails to charge the rails. Let's go over the high voltage light bulb circuit first. Okay, this is the same circuit I built with the light bulbs, except I've replaced those light bulbs with LEDs. So the circuit that we're switching is, we have it connected to positive. This resistor is connected to positive. It's flowing in through this terminal, which is coming down the center. And if you look on here, it shows that it's currently switched to the right, which means the electricity is flowing down. It's going to go out this terminal to the yellow one. And if I currently have it the way that it is, this light will be charged. That is the one that is going to be charged. Okay. Now, when this port 9 is turned on, okay, port 9, this is going to flip. And when that flips, electricity is going to be now flowing, okay? It's always flowing through here. It's just we're controlling which direction it's going with the control circuit. So this is going to flip over, and then electricity is going to come down through the purple wire out and connect up through the LED and return to the negative section. I think all of us have used Tinkercad before. If you have not, it's pretty self-explanatory. You can drag stuff in. You can move wires. You can change, if you click here, you can change the color of wires for organization. If you click on a wire, you can then drag where it's connected to. To create a wire, you just click in a spot, and you can take nice, beautiful 90-degree turns. Oh, that is just satisfying. That is just so beautiful. Look at that. Oh my gosh. That, man, beautiful. Okay, anyways. Yeah, so that's our flowing circuit, that our high voltage circuit that we're controlling. Theoretical high voltage circuit. Okay, now the low voltage circuit, or the control circuit, or the, what did it call it? No, that load is the other one. Whatever, input circuit. So if you are turning this on, you are opening up this transistor. Now the transistor is just a switch too. So why are we using transistor here? Well, you really don't need to, because this is controlled by 5-volt, and that's what these are. I want you to practice with transistors though, because if you just do simple circuits with relays, I don't know, it's not the same. You need to, everything that electrical engineers do pretty much involves little transistors that you're controlling with. So let's practice with them, so we understand them, right? Remember, you have your collector. Your collector is going to go to positive. Collector goes to positive. Emitter goes to negative. So I have the collector coming in, connected to positive. Electricity flowing from positive to negative. Now, currently, as it stands, this transistor is not going to be allowing any electricity to flow from the connector to the emitter, only when port 9 is activated. So when we turn port 9 on to high, now electricity is flowing through the emitter, blip, down this wire all the way into this channel, and it's going to come through here. We have a parallel circuit bouncing off to go to this flyback diode, okay? But don't worry about that now. It's going to come through, and there, if we look at our circuit, there's our coil. There we have an inductor. We're going to charge up that coil, which is going to create a magnetic field, which will suck that over, and then when that turns off, so the electricity is flowing through, and then it returns to ground and goes home, okay? So when electricity is running through there, this flips, right? Electricity goes to here, opens this, electricity comes through, flips that, and when that shuts down, the magnetic field collapses, and our electricity dissipates in our flyback diode. That's what happens. This is 20-minute. How did I make this a 20-minute video? I'm really sorry. I'm sorry. I'm sorry for what I've done. Yes. If this is not enough information for you, or if you are struggling, I mean, this is a basic, or this is a lot of information maybe for people that have not used Tinkercad. I don't know how many that is. But you can just sit here and practice with other stuff too, if you'd like. You don't have to, you still have to do your assignment, but please get warmed up. Take the time you need. That's all I'm giving you for the week. I want you to make this, this relay program. So let me go to the assignment, which is right here. So your assignment, let me drag this up onto the screen here. Your assignment is to make a system that replicates a three-way switch. Your electrical system should contain two relays controlled by two separate output ports, okay? Those ports represent these switches, okay? So they're going to be in on and off states, okay? Let's see here. 2 transistors for each relay, 2 flyback diodes, 1 for each relay, 1 LED, you're only controlling 1 light, and 1 330 ohm resistor. And that 330 ohm resistor is in the high voltage circuit that's turning the LED on. Each port will control a transistor. Now here are the restrictions or the constraints. When both ports are high, the LED is off. When both ports are low, the LED should be off. When one port is high and the other is low, I want the LED to be on. Excuse me, just fixed that. Whew, dodged a bullet. When one port is high and the other port is low, the light or the LED should be on. That's the plan. Hopefully this explained enough, and if you have further questions, just show up to either office hours, which can be found on my website in the remote education plan on each page, and also the class time. We're going to answer questions. We're going to discuss the future of engineering design. I miss you guys. I wish that I could hastily eat my beans and sweat it out with hot sauce, and then try and build trebuchet wheels for a month with you guys. That just sounds like a lot of fun, and anyways, hope everyone's doing all right. I'm going to try and keep these lessons pretty light if we can. So I know you guys got a bunch of other stuff you're working on. So miss you. Write me on Google Classroom or something. Okay, we'll see you later. Bye.